All right, week 4, day 2. So the first lesson for week 4 was multiplying rationals. So today we are going to divide rationals, okay? The nice part about dividing and multiplying is they're very similar, and so hopefully this lesson's a lot shorter than it was on the first one. Dividing rationals, we are going to simplify rational expressions using division. What I'm going to start with, though, however, is just dividing something you already know. Okay, so for instance, 7/8 divided by 1/4. Big key thing about division is remember that you want to actually change this so that you are multiplying by the reciprocal of the second fraction. So by 4/1. A lot of you know it as keep, change, and then flip. I hate that term, but I'm going to use it in this situation because it's the best way to reach most of you. But 7/8 times 4/1 is the same thing as dividing by 1/4. Then remember you want to multiply, or you can cross simplify first if you want to, and simplify those two right there. You could have multiplied it straight across and had 28/8, and it still would simplify to the same thing as 7/2. Okay, so again, dividing is a lot like multiplying, so this is going to be hopefully a very much shorter lesson than the day 1 was for this week. Here's the first problem here we're going to start with. M squared minus 9 divided by 3 minus m over, how about we try this again, m squared minus 9 divided by m squared plus 5m plus 6, then divided by 3 minus m divided by m plus 2. Two ways you could go about this question. You could start by changing this to multiplication right away. So I'm going to keep that first one the same. I want this to now be multiplication instead of division. And I'm going to take this fraction and write the reciprocal. Okay. What I want to do here is we're going to factor the m squared minus 9, and we're going to factor the m squared plus 5m plus 6. Alright, reminder that m squared minus 9 is a difference of two squares, and we'll factor this way. M minus 3 and m plus 3. Okay, I take the square root of both, and I have to make it a difference, so I have a negative and a positive. Factoring the denominator. Okay, factoring the denominator of that second fraction, or that first fraction, m squared plus 5m plus 6. We are finding what multiplies to 6 and adds to 5. So I'm going to do this off to the side over here. M squared, what multiplies to 6 and adds to 5 is 2 and 3. Remember, I'm going to simply group and take out what they have in common. And so that the denominator of that fraction becomes m plus 2 times m plus 3. Now that second fraction has not changed. M plus 2 on the numerator and 3 minus m on the denominator. Once it's written here in multiplication, remember this is like one gigantic big fraction. Okay, so anything that is the same on the numerator and the denominator, I can eliminate. So, for instance, my m plus 2 is the same. My m plus 3 is the same. Now, m minus 3 is not the same thing as 3 minus m. They are very similar, but they are not exactly the same. If I were to rewrite this fraction, I would have m minus 3, and this is a negative m and a positive 3. Now, is there a way to make them the same? The answer to that question is yes. What could I take out of this denominator that would make it exactly the same as that numerator? Well, the answer is I can factor out a negative 1. When I factor out a negative 1, I have m minus 3, a positive m and a negative 3, so that this also will simplify. and I have a final answer of 1 over negative 1, which is just simple, negative 1. Okay, so all of that at the beginning just to get a simple answer like negative 1 at the end. All right, what we have here is called a complex fraction. Now what makes it complex is that I have a fraction over a fraction. But remember, I can take this 1/5 divided by 3/25, and I can rewrite this to 1 over 5 and just rewrite it the long way. And now it becomes no different than the questions we were already doing. So for example, 1 over 5 times 25 over 3. I can multiply straight across if I want to and have 25 over 15, which I will then simplify to say 5/3. You could have cross simplified as well and you would have still gotten 5/3. So how is this going to play into what we're doing today? This one right here is a complex fraction, r to the third times s divided by t, all divided by rs to the third divided by t to the third. Now remember, although that looks disgusting, it looks complex, remember it means nothing more than this, r to the third s divided by t, and then divided by rs to the third divided by t to the third. Okay, you cannot cross simplify in the division state, so meaning I cannot look at diagonals and try to get rid of anything when it's in a division problem. But as soon as I change this to say r to the third s divided by t times t to the third over rs to the third, I can now simplify my diagonals if I want to. Meaning, this t and this t to the third will simplify so that I have a t squared left. R to the third and this r will simplify so that I have r squared left on my numerator. Same thing with this s and this s to the third so that I am left with s squared down here. So my final answer when I look across my numerator at what is left, well, I have on that numerator r squared, t squared. On the denominator, I just have s squared. And I have to go backwards a little bit because I did some big fat no-nos throughout this entire lesson. For example, over here, I forgot to mention what can m not be. Okay? M, on this question, when it is in factored form, I cannot be anything that's on my denominator. Okay, so, so here's my factored form, which is down here. M cannot equal -2. M cannot equal -3. And believe it or not, that -3 also stays for that 3 minus m. Ooh, actually I lied. That 3 minus m actually means that m cannot be +3. Okay? Now, I do need to do that here on this question, and I'm going to do it right here because the only variables here, I have all of them on my denominator. That means r cannot equal 0, s cannot equal 0, and t cannot equal 0. I will do better on this last example here. So here's this complex fraction. Now this one, I have that y squared plus 5y plus 4. That's the only part of the numerator. It is being divided by y squared minus 1 divided by y plus 5. Now the only thing I'm going to give you here is a reminder that, hey, this is actually over 1, so that when you change this to be written as multiplication rather than division, you have your y squared plus 5y plus 4 all divided by 1 is multiplied by y plus 5 divided by y squared minus 1. What I'm going to do here is I want you to pause and factor the two areas that can be factored, the numerator of the left and the denominator of the right. Alright, there's what you should have had when you factored those. Okay, right here I'm going to say what y cannot equal. Y cannot be 1 and y cannot be -1. Remember, I could care less about the numerators. when I make this one giant fraction and simplify, what is the only thing that can eliminate? Well, that is the y plus 1. And so I am left with, on the numerator, y plus 4 times y plus 5. The denominator, I am left with y minus 1. And there's my simplified answer. Thank you for hanging in again today. Hopefully you've had a great week.